Welcome to part 5 of this Unreal Engine 5 tutorial series where we build a smart enemy AI system inspired by the Xenomorph AI from Alien Isolation. In the last video, we created our alien NPC character, set up its AI controller, and added a state tree to drive basic rudimentary behavior. In this video, we're going to add sight perception to our alien character so that when it sees the player, it will change to an attack state and chase the player. To achieve this, we will be adding the AI perception component to our character, then expanding upon our state tree to process this sight stimulus information and change behavior to various attack states based on whether or not the alien has lost sight of our player character. In addition to this lesson, there will also be a follow-up bonus lesson discussing the unique approach that the developers of Alien Isolation took when implementing sight perception into the alien's AI, and also some various strategies of how to implement a similar approach in Unreal Engine 5, using either the base engine or paid plugins. These examples will not be required in order to follow along with the series, but they are included in order to expand your game development knowledge. As always, the project files for this video will be made available to download from Gumroad completely for free. However, if you would like to support the work that I do, please consider supporting this channel by making a donation via the link in the description below, or by adding a monetary amount in the Gumroad link if you choose to download the project files. If you enjoy the content, please like the video and consider subscribing to the channel. There's a lot to cover in today's lesson, so with all that out of the way, let's get started. Now, before we get stuck into the lesson, let's expand this level a little bit so that we've got a little bit more space to work with. So I'm just going to delete some of these assets on the side of our map here. I'll select the floor mesh, press the F key to get a center view. I'll press and hold the Alt key and then drag this to the left to duplicate. And then I'll just line this up so that it's aligned with our floor mesh. There we go. Now, if you remember from the last lesson, we also added in a nav mesh bounds volume, which defines the navigable area for our NPC. If we press the P key, it will bring up that navigable area again. So we also want to expand this to cover the new section. So I'll press P again and then select our nav mesh, press Alt J to enter the top-down wireframe mode. And then I will just shift this into the center of the two floors. Press the R key to scale, and then expand this to cover the new floor area. And then press Alt G, and now if we press P again, you'll see that the navigable area has now expanded to cover the entire floor. Now we'll go back into our state tree in a moment, but before I do that, I've decided just to reorganize some of these assets a little bit. So if we go back into our Tute content folder, Blueprints, AI, Alien, I'm just going to reorganize this slightly. So I'm actually going to bring the state tree up into the alien folder and click move here. This may take a little while because it's just renaming all the references. Great. And when that's done, we'll keep this state tree folder for subtrees that we create later in the series. I'm also just going to go into our state tree tasks, and I'm going to move the base task into the alien folder as well. Click move here. And then finally, in our task folder, I'm going to move this child tasks into our ST tasks folder. Go back to our ST tasks folder, and just before I delete this, I'm just going to right click on the top content folder and then select update redirector references. Once it's fixed up all references, in this case there were no redirectors to fix up, I'll just select delete unreferenced redirectors, and then go back into our Tute folder, Blueprints, AI, Alien, and then ST tasks, and then just delete this folder. So this is just to keep things a little bit more organized. So in this folder, we're going to keep our base classes for the AI. So in this case, the AI controller, the main behavior state tree, our base task, and any child tasks or subtrees will go into subfolders here. So now that that's done, let's open back up our behavior state tree. Now, one thing that I like to do with state trees is I kind of like to plan ahead what I want the behavior to do. So currently we have a search state which involves moving to a random location in the world and then just repeating that behavior over and over again. What we want to implement is a way to change our state to an attack state once our alien sees our player character. So I'm just going to select our root and add a new state, and we'll call this attack. And I will add a color scheme for our attack as well. So we'll add a color scheme for attack, and we'll make this a nice red color. And to try and improve readability a bit, I'm just going to tone down the brightness of this green to something a bit more readable against the white text. And just update the color, and there we go. So now what we will have is two fairly broad categories of branches. We've got a search branch, and now we've got an attack branch. So when our alien AI character sees our player, we will change from a search branch into an attack branch. And as we branch down further into our attack branch, we'll also be updating our behavior based on whether or not the alien can still see the player or whether or not it loses sight of the player. So we'll right click attack and add a child state and call this has attack target. And we'll also create another child state and call this search for attack target. And we can also update our color scheme for these two states as well. And now that we have our two broad behavior states, we can think about what we want the alien character to do in those behavior states. So if the alien does have an attack target, we obviously want to move the alien towards our attack target. So we'll add a child state of has attack target, and we'll call this move to target. And we're just going to keep this very simple for now. We'll add a more refined attack state later in the series, but I'll just create another child state of has attack target, and we'll just add in a wait task as well. But what if the alien loses sight of the attack target? What do we want the alien to do? Well, we might want the alien to move to the last known location of our attack target. So we can create a child state of this one and call this move to last known location. And then we'll also just add a wait state as well. And we'll update the color scheme to attack. Great. So we've created a bunch of empty states now, and this just allows us to give ourselves a rough plan for what we want our alien character to do once the conditions change. So now that we have a broad plan for how we want our alien NPC to behave, let's implement the perception component. So let's go to our content drawer and open up our custom AI controller. And to add our AI perception component is very simple. We just go over to our components panel here, click the add button and type in perception. And we have two different options. The first one is the AI perception component itself. This is what registers the AI sense stimulus received from the world. And we also have this AI perception stimuli source component. Now, this is a component that you would use on an actor that provides a stimulus to be detected by an AI perception component. But by default, a pawn or a character can already be detected by an AI perception component without the need to add this component to them. This is something that you would use to add to an actor that you want an AI to detect that isn't a character or a pawn. Okay, so for now, we'll add the AI perception component and we'll just leave the name as default. Now, when you add the AI perception component, we now have access to adding the different sensors available to us. We'll go down to the AI perception area in the details panel, and under sensors config, we will click the add button to add a sense. And we also get a drop down to choose the type of sense we want to implement. In this case, we want to implement a site sense config, so we will select AI site config. Now from here, we can expand this index out so that we can get a bit more customization over our site sense. The site radius is the radius with which the AI can detect an enemy. The lose site radius is the radius at which the enemy can no longer see the player. It's gone beyond its line of sight. The peripheral vision half angle is the angle of the vision cone that the agent uses to see in the world. The next option is detection by affiliation. We'll just expand this, and we actually need to make sure that all three of these are checked. Otherwise, this system won't work properly. We don't need to worry about these too much. This is more for a C++ implementation, but we do need to make sure that all three are checked. Otherwise, this won't work properly. And the next option is the auto success range from last seen location. We won't be using this, but what this basically means is that if this value is assigned as a valid range, it means that the agent will always be able to see the target that has already been seen if they are within the range of the last seen location. If, however, it's set as an an invalid range, which it currently is, then this setting is not used and we won't be using this one. Next, we have the point of view backward offset. The point of view backward offset is basically a way to move the vision cone backwards behind the character's head by a certain amount. So it's as if the vision cone actually starts behind the character itself. Now, the reason why that we have this is it can be used in conjunction with the near clipping radius. So the near clipping radius is essentially creating a peripheral vision that's close to the enemy target. And then next we have the debug color, which will be the color of the vision cone that we can use to debug in the world. And then finally we have the max age. The max age is basically how long the agent will remember a seen target before it becomes forgotten. So by default it's set at 0. This means that it will never forget the target. We are going to make use of this setting. For our sight radius, we're going to change this to 1000 or 10 meters. Our lose sight radius, we'll change this to 1500 units. In our peripheral vision half angle, we will change this to a value of 45 degrees. So let's go to our level. We're going to select our alien character and then just drag him into a more open area. And let's rotate him so he's facing the front. And for now, what I'm also going to do is I'm going to go to our AI controller and select our state tree. And I'm just going to uncheck start logic automatically. And this will mean he's just going to stand still. So now when we press play, the state tree won't activate and our alien will just stand idle. Let's go back to our level and we'll move the player start. Just press the end key to bring it down to the ground. And just to get a better perspective of our scene when we press play, I'm just going to make a quick change to our third person character. So we'll go up to the content folder, go into third person blueprints, and then open up the third person character. And I'll just right click in an empty area and type in debug tab, and we'll select debug key tab. And when pressed, we'll drag off and create a flip-flop node, and we'll select the camera boom and drag that out into the event graph, and then drag off and type set target arm length. Hook that up to the A output, and we will set the target arm length as 1500. We'll duplicate this, hook that up to the B output, and then change this value back to the default of 400. Compile and save. So now when we go to our world and press play, if we press the tab key, it gives us a bit more of a wider perspective on what's happening. Now, to view the debug information of our NPC character, while the camera is facing the NPC character, we can press the quotation marks key. This is the key that's directly left of the enter key on the keyboard. Now you'll see here that there's a number of different options that we can choose from. If the options highlighted green are currently displaying and the options highlighted gray are currently disabled. We can go ahead and disable the current debug information that's been displayed by pressing the 1 key to disable the AI information and the number 2 key to disable the behavior tree information. We don't use behavior trees in this series, so that information will not be relevant in any case. But now what we can do is we can activate the perception information by pressing the 4 key on our number pad. Now we can see the vision cone, which is at a 45-degree angle on both sides. We also have a green inner radius, which represents the sight radius. So if we go inside that sight radius, the enemy now sees us. And it will continue to see us until we leave the lose sight radius. And it won't see us again until we re-enter the sight radius. It will also lose sight of us if we leave its vision angle. Now, when our NPC character loses sight of our player character, you'll notice that the age value is increasing every second. Now, because we haven't set the max age for our sight sense, this will continue forever until the character sees us again. However, if we leave the game and go back and set a max age of 5 seconds, compile, save. So now if we press play, hit the tab key and then the quotation key, when we enter our enemy's line of sight and then leave the line of sight, the age will count up to the number 5, and then the player character will be forgotten. We will keep this at a value of 5 for now. escape out of that, and we'll go back to our AI controller. And then I also mentioned the point of view backward offset and the near clipping radius. So for example, if we set this to a value of 250, if we press play, hit the tab key, you'll notice that the vision cone is now starting 250 units behind the enemy AI character. To add a value under the near clipping radius of, let's say, 250, and then press play, you'll notice that it sort of forms this area of peripheral vision around the vision cone. This can be useful when you don't want the player to be able to sneak up to the side of the character. So we will use a point of view backward offset value of 250 and a near clipping radius of 175. And then when we hit play, you'll notice that there is a peripheral vision area, which includes an area behind the alien as well. In the game Alien Isolation, the alien actually has a small area of peripheral vision around its entire body. And this is to stop the player from being able to sneak past the alien at a close angle. So this is the value that we will use. Now let's explore some of the events that we could use with our AI perception component. So let's go back to our AI controller. And with the AI perception component selected, if we scroll all the way down the bottom here, we have this events section. Now, these are some important events that come with the AI perception component. I'm going to add all of these to the event graph and give a brief overview. So we'll add each one. Now, some of these events operate in quite a similar way. On-target perception updated provides us with an array of all the actors that are currently perceived by our perception system. On-target perception updated will provide us with the actor that has updated our perception system, as well as some stimulus information as well. So if we were to drag off this stimulus pin and then scroll all the way down to the bottom and select break, this gives us certain information about our stimulus received from the world. So the age of the stimulus, expiration date, the strength, the stimulus location, receiver location, tag, and whether or not it was successfully sensed. Go ahead and close that. An on-target perception info updated is also very similar. If we were to break this struct, it provides us essentially the same information. So we have the target, the stimulus, but it also provides us with a target ID. Next, we have on-target perception forgotten. Now, this is fired when our agent forgets the character. This will be triggered once our max age value has been reached. And then finally, we have an event for when our component is activated or deactivated. The events that we will mostly focus on will be the on-target perception updated and the on-target perception forgotten. But what we will do is that rather than handling these events inside our AI controller, we're going to handle them in a state tree evaluator. We'll go ahead and delete these, compile and save, and we'll go back to our state tree. If you'll recall from part 3 of this series, we did cover a brief overview of evaluators, but now we're going to actually create an evaluator. Now, there's no way to create an evaluator in a similar way to how we might create a new task. So to create an evaluator, we would go to our content drawer, go to our Tute content folder, Blueprints, AI, Alien, and in this folder here, I'm going to right click and select Blueprint class. And then under all classes, we'll type in state tree eval, and we have this option here, state tree evaluator blueprint base. We'll go ahead and select that, and we will call this steval underscore alien underscore evaluator base. Open that up, and similar to our approach with our state tree tasks, we're going to create a base evaluator, which we will then derive child evaluators from. So we'll go ahead and create a variable, name this alien character ref, and this will be of type BP MPC alien object reference. And we will also create a new variable, call this alien AI controller ref, and this one will be of type AIC NPC alien object reference. And of course, we will assign these to the special category of context. So we will type in context, and then we'll select the other one, and then just select context from the drop-down, compile, and save. So now we have our base state tree evaluator. Let's go ahead and create a child of this evaluator. I'm going to create a new folder, call this st evaluators. Then we'll right-click our base evaluator, create child blueprint class, and we'll call this st eval underscore evaluate perception. And then just drag this into our evaluators folder. And we'll open that up. Now we have a child evaluator with access to our context variables. Now, something I neglected to mention in the previous video, if you don't see these variables, make sure that you select the cog settings up here and make sure that show inherited variables is selected. Now, state tree evaluators may seem very similar to state tree tasks. We have the event graph, overridable functions, macros, and variables. But unlike state tree tasks, evaluators do not have explicit ways to finish, as evaluators are intended to run continuously, constantly updating and evaluating information. In our overridable functions, we have, of course, the tick function. We also have the tree start function, which fires once when our state tree starts. And we have the tree stop function, which also fires once when our state tree finishes. I will go ahead and add the tree start event and the tree stop event to our graph. Now, this state tree evaluator will be used to handle the events from our AI perception component. Now, back in our AI controller, if we have the AI perception component selected, it is very easy to simply add these events to our event graph. But in our state tree evaluator, we don't have the same option. So how would we implement these events? Well, what we would do is we would create our own custom events that would be bound to those events that fire in our AI perception component. And to do that, we can drag off our alien AI controller ref and select a get. Then we need to get a reference to the AI perception component. So we'll search for get AI perception. That should all be all the way down the bottom here. Drag off and type in bind event to on target perception updated. And we'll hook that up to tree start. Now, the way that this binding node works is that it requires an event to bind to our on-target perception updated event in our AI perception component. If we try to compile, we will be given an error saying that event dispatcher pin is not connected. One of the most common ways to create a custom event from here is to simply drag off this and select add event and then add custom event. But what we'll be doing instead is dragging off this pin and adding an event dispatcher and then create event. And now what we can do is we can either create a matching function or create a matching event. We will select create a matching event. And we will call this on target perception updated. And then now when we compile, that error goes away. So now we have our own custom event, which is bound to the event from our AI perception component. And because this is a matching event, we have the same variable outputs as well. Now we'll go ahead and we'll also drag off and type in bind event to on, and the one we want is on target perception forgotten. We'll hook that up. And same as last time, we will drag off, select event dispatcher, create event. We will create a matching event and call this on target perception forgotten. Compile and save. So when our state tree starts, it will bind these custom events to the events from the AI perception component. What we can also do is that when the tree stops, we can unbind these events just to clean up our code. So I'm going to get another reference to our alien AI controller and then get the AI perception component. And this time we will unbind event from onTarget perception updated. We'll hook that up to the tree stop. And then we can just connect the delegate to the same event dispatcher. Then we'll drag off from our AI perception again, do unbind event from onTarget perception forgotten. And then hook up the delegate like so. Compile and save. And now just to clean up our code a little bit, I'm just going to highlight all of this, right click, and then collapse nodes. And I'll call this setup bindings on tree start and stop. The execution input, type in tree start. And on the second one, tree stop. And now let's update our logic from our onTarget perception updated event. The first thing we will do is we will promote our actor to a variable, and we will call this perceived actor. And we will also promote our stimulus information to a variable, and we'll call this received stimulus. Next, what we will do is we will drag off from the output pin and break the stimulus information. And we want to check whether or not the player character has been successfully sensed. If the player has been successfully sensed, it means that the character has entered the alien's line of sight. If it has not been successfully sensed, that means that the alien has lost sight of the character. So we'll just drag off and add in a branch and hook that up like so. And I'll also select this node here and hide unconnected pins. And if successfully sensed is true, we will add in a Boolean variable and call this received any sense stimulus ? And set that to true. Next, what we'll do is we'll create a function to handle our sight sense stimulus. So we'll go over to functions and click the add button and call this handle sight stimulus. Now we need to check whether or not the received stimulus is of type sight sense. So we'll drag out our received stimulus variable and search for get sense class for stimulus. Then equals, and we will select AI sense sight, and we'll select this one here, AI sense sight. Drag off and search for an and Boolean, and we'll also make sure that received any sense stimulus is also true, and then create a branch. And if this is true, it means that we have received a sight stimulus. So we'll go ahead and add another Boolean variable and call this received sight stimulus ? And then add that to the true pin and mark that as true. Finally, we will drag off a reference to our received stimulus again, and we will break the AI stimulus. And out of successfully sensed, we'll add another branch. And if successfully sensed is true, that means we can see the target. So we'll add a Boolean, call this can see target ? Drag that onto the true pin and mark that as true. And just to clean this up, again, I'll select the break node and hide unconnected pins. Compile and save. So just to recap on our handle site stimulus function, we will first check to see whether the stimulus is of type site sense and whether received any sense stimulus is also true. If both of these conditions are met, then we have received a site stimulus. And if that actor is successfully sensed, that means that we can see the target. Next, what we will do is we will create a new function to set the alien's acquired target. So we'll go to functions, add a new function, and call this set acquired target. And for this function, we want to set a variable that will store a reference to the acquired target that the alien is currently perceiving. So we'll go ahead and create a new variable, and we'll call this acquired target. And this will be of type actor and object reference. And before we set the acquired target, we just want to make sure that there's not already a reference that has been set. So we'll drag this out as a get node, and we will right click this node and select convert to validated get. And what a validated get node is it's exactly the same as a get node, except it gives us the option to check whether there is a valid reference or whether there is not a current valid reference. Now, if there is not a current valid reference, we want to set a valid reference. So we'll drag off our acquired target variable and select a set node. Hook that up to is not valid, and the reference we will set is the perceived actor. So we'll drag that off and drop that onto the pin like so. Once we've set our acquired target reference, we will get a reference to our AI controller, and we will make use of a function called set focus. And it's this one here, set focus. We'll hook that up like so. And then we will set focus to our acquired target. What the set focus node does is it focuses the line of sight onto the reference that we set. And now that we've set focus, we now need a way to change the AI character's behavior in our state tree. We'll go back to our state tree alien behavior. Now we need a way to determine whether or not our character should be in the search branch or in the attack branch. Perhaps the more obvious answer would be to simply change to the attack branch once the NPC has seen the player. So we could make use of the canSeeTarget variable that we've created. However, this would be quite an inflexible approach because a Boolean variable only gives us two options, either a true or a false, which is fine if all we have are two options to choose from. But because we'll be expanding upon this state tree, we need something a bit more flexible. If you recall from the second part of this series, we discussed how in the alien's behavior tree, the flow of logic was being determined by checking the alien's current motivation. We're going to implement something similar and make use of gameplay tags. So we'll go to parameters, we'll add a new parameter. We will rename this to motivation, and we will set the type as gameplay tag. And I'm just going to create two gameplay tags to choose from. So let's go to our alien folder and then right click, create a new folder, call this data tables, open that up, right click, and then select miscellaneous, and we will add a data table. And the one we need is called gameplay tag table row, and hit OK. And we'll call this DT underscore alien underscore motivation. Double click that. We'll create two simple tags. So the first tag, so we'll add in a row, and then under tag, we will call this one alien.motivation.search. Then we'll create a new row, and this tag we will call alien.motivation.attack. And then save. Now we just need to implement this into our project settings as well. So we'll go to Edit, Project Settings, then under Gameplay Tags, and then under Gameplay Tag Table List, we'll add a new table list, and then select DT Alien Motivation. And now we'll go back to our Evaluator, and we now want to make a change to the alien's current motivation. So we will create a variable and call this motivation param, and this will be of type state tree property reference. And if you recall, we just need to compile it before we can set the reference type. And the reference type will be gameplay tag. And remember, we also need to expose this to the editor so that we can bind this to our parameter. But let's drag this onto the graph, get motivation param. We will get property reference. Again, we'll make use of the set by reference node, hook up the reference to target, which will change it to a set gameplay tag node. Hook that up to succeeded. We will set the gameplay tag to alien motivation attack. Now, if our get property reference node fails, we can add in a return node to exit the function, and we can add a return node at the end of the set by reference node as well. Now we'll just make use of this function. If we go back to our handle site stimulus function, we will drag in the set acquired target node and hook this up like so. So if our alien can see the target, we will check to see if there is already a valid acquired target reference. If there is not, we will set the acquired target. Then we will set the AI controller focus and then update our alien's motivation to an attack motivation. But there might also be a situation where we already do have a valid reference to the acquired target, in which case what we want to do is we just want to check whether the reference is equal to our perceived actor. Then add a branch. And if our acquired target is already set to our perceived actor, then we will simply hook this up to set focus again. But if our acquired target is not currently our perceived actor, we want to set the acquired target to our perceived actor. And let's just clean this up. And now let's go back to our event graph. And we will add our handle site stimulus to the event graph and add it to the end of this logic. Now let's test to see if this evaluator is working. We of course need to implement this evaluator into our state tree. So let's make it a little bit more readable. So we'll go up and make sure the class settings is selected. And then under blueprint category, we will type in alien NPC perception. And then under blueprint display name, we will call this evaluate perception stimuli. Compile and save. And we'll go to our state tree. And then under evaluators, we will add in evaluate perception stimuli. Now this won't compile unless we bind this to our motivation parameter. So let's go ahead and do that. Compile and save. We will go back to our evaluator, and just to make sure that this is updating our acquired target, we will drag off and create a print string node. And we will drop in a reference to our acquired target. And one final thing that we need to do is go back to our AI controller, select our state tree component, and then make sure that start logic automatically is re-enabled. Compile and save. And I'm just going to move this backwards a little bit, and we'll hit play. And now when we enter our enemy's line of sight, we get a reference to the third person character printed on the screen. So now we've gathered and processed some site stimulus information from the world, but now we need to change the alien's behavior. So to do that, we'll go back to our state tree, and we need a way to check the current motivation of the alien, whether he's currently motivated to search or whether his motivation has been updated to attack once he's seen the player. Now, we have had some experience adding enter conditions previously. If we select the search state and then drag this out here and press the enter condition, you'll notice that there are some different ways that we can compare information. So there's a Boolean compare, which we've used in the previous video. There's an enum compare, a float compare. Now, we also have this section for gameplay tags. However, if we were to select the has tag enter condition, you'll see that this is not actually checking against a gameplay tag, but rather this is checking against a gameplay tag container. Now, we will explore gameplay tag containers later, But for now, I thought this would be a good opportunity to explore how to create our own custom conditions, specifically to check whether or not a gameplay tag, in this case our motivation gameplay tag, is of a certain type. So for now, we'll just go ahead and remove this. So what we'll need to do is we'll need to create our own custom condition. To do that, it's fairly straightforward. We can just click on this new condition option here and then select state tree condition blueprint base. I'll create a new folder and call this st conditions. Go inside there and we will name this stcon underscore compare gameplay tag. Enter. Now, the way that we create a condition is very straightforward. What we need to do is we need to go over to the override functions here, and we have these two functions that we can override: the get description, which we'll discuss in a moment, and we have receive test condition function as well. We will go ahead and override this function, and what we're presented with is a function with a Boolean output. What we want to do is we want to check whether or not a gameplay tag is equal to a specific tag. And to do that, we're going to make use of the following logic format. We have the left gameplay tag, the right gameplay tag, and the operator. So we'll create a new variable. This will be called left tag. This will be of type gameplay tag. And we'll add a new variable again, and this one will be called right tag, which will be of type gameplay tag as well. Now from our left tag, we want to check an input referenced. So to do that, we can simply change our category to input so that we can bind it in the editor. And for our right tag, we want to set this from the editor, so we will expose this to public. Now all we need to do is to drag our left tag onto the graph and search for matches tag. And we want to check if our left tag matches our right tag, and hook that up to the Boolean output. Now, gameplay tags are very flexible, and we have this option here that says exact match. Now, for example, if we are comparing two gameplay tags and both are of type alien.motivation.attack, then it means that these gameplay tags match. But if our left tag is alien.motivation.attack.tryfindtarget, then both of these gameplay tags still match if our left tag is alien.motivation.attack.tryfindtarget and our right tag is alien.motivation.attack. If we leave this Boolean unchecked, it means that these two tags will match. But if we check this, it means that the tags need to be exactly the same. Now we want to set this Boolean from the editor as well, so we'll promote this to a variable, leave the name as exact match, and then we will expose it to the editor, compile and save. And now when we implement this enter condition, we'll have the search state selected. We'll add an enter condition and select compare gameplay tags. Our left tag shows the input description, so this needs to be bound. So we will bind this to our parameters motivation. For our right tag, we will set this as alien motivation search, and we will leave exact match unchecked in case we want more specific gameplay tag events in the search branch. Now, one thing that you'll notice here is that the current description does not give us much information about what this enter condition is actually checking. All we get is the blueprint display name. It would be nice to add some more information to let us know what this is actually trying to achieve. So to do that, we can go back to our condition, and then under override, we can select get description. And when we override the get description node, we override the description that is displayed in this area here. And to do that, we can drag off this text input variable and type in format text. And the way that a format text works is that when we type something in here, if we add a condition in a curly bracket, it will add an input pin. So for example, if we write tag curly bracket left curly bracket and then enter, you'll notice that we've now added a wildcard input. Now the format we'll be using to display our description will be as follows. We'll have tag with a description of what the gameplay tag is bound to. We have the operator, and then finally the actual gameplay tag that we're comparing. So let's add in this now. Go back to tag, and then I'll just add a square bracket on either side of the left and then space, and in curly brackets, we'll write operator, and then space again, and in curly brackets, right. And then enter. So now we have a left input, an operator input, and a right input. If we compile and save and go back, you'll see there's not much information displayed at the moment. For the left input, we want to get a description of what we're binding our input to. There's no easy way to do this in Blueprints as far as I'm aware. So what we'll do is we'll just create an enumeration. If we go back to our alien folder and then create a new folder, call this enums, we'll right click, blueprint enumeration, and we'll call this enum underscore binding description. We'll double click that. We'll just create two enumerators for now. The first we'll call this unspecified. And in the second one, we'll call this parameters.motivation. And then save. Go back to our condition and add in this as a variable. Call this binding description, and this will be of type enum underscore binding description, and we will expose this to the editor. Compile and save, drag this out, get binding, then we'll drag off this node and type into text, select this one, and then hook this up to our left input. Our operator will have two different options available. Either exact match will be true or it will be false. So we'll drag off operator and type in select text and then hook up our exact match boolean into the boolean input. If exact match is true, we will type in is exact match colon. And if exact match is false, we will just type in is match colon. And finally, for the right component of our argument, we just want to get the display name of our gameplay tag. So we'll drag off the right gameplay tag, select get, and then get tag name, and then to text, and then hook this up like so. Compile and save. Now once we go back to our state tree, we now have if tag unspecified is match for alien.motivation.search, and we can set our binding description to parameters.motivation. And now we have much more information available to us. So if tag of parameters.motivation is a match for alien.motivation.search. So this gives us a lot more information when we read our state tree, particularly for other people who may be working with us. We'll do the same thing for our attack state. So we'll select attack state, and under enter condition, we will add a compare gameplay tags. We will bind the left tag to our parameters motivation. And we want to check to see if the gameplay tag is of type alien motivation attack. We will leave exact match unchecked, and we will change the description to parameters.motivation. And now that both of our branches have an enter condition, we just want to make sure that motivation has a default value set. So we will change this to alien motivation search. So by default, we will enter our search branch. And one final thing we could probably add here is adding in some bold text for the operator. So if we go back to our condition, before the operator, we can type the less than symbol, the letter B, then the greater than symbol. And then after the operator, type the less than symbol, a slash, and the greater than symbol. If we compile that, we go back to our state tree. It's a little bit difficult to see, but you'll now see that that operator is in bold text. And now we'll go back to our evaluator. Now we also have a number of variables here that we can make use of by exposing to our state tree. And we can do that by using the output category. So if we select our received any sense stimulus boolean under category, we can type in output. And then we will add our other two boolean variables to this category as well. And we'll also add our acquired target variable to this category as well. And if we go back to our state tree, you'll now see that all of these variables have been exposed to our state tree, which we can make use of to govern behavior. And the first thing I'm going to do is add another enter condition to our search state. So select search state. I will add a new enter condition, and this time I will select bool compare. For our left input, we will bind this to evaluate perception stimuli and received any sense stimulus. We want to make sure that this Boolean is false. And you'll notice now that we now have a new operator added to our argument. This means that both enter conditions need to be valid in order to enter this state. If you wanted to change this, you could select this option here and select OR, but we will leave this as an AND operator. Now we'll select our attack state and add a new enter condition of bool compare. We will bind this to the same Boolean, received any sense stimulus, and this time we want the Boolean to be true. But now we also need to add in a transition rule to make sure that we transition from our search branch into our attack branch once a sense stimulus has been received. By default, our alien character will move into a random location and then waiting for 2 seconds, and we can't always determine which of these states the alien will be in when it sees the player. But we don't need to enter a transition rule from either of these states, because when a state is active, its ascendant states are also active as well. So whether or not the character is in the move to random location state or the wait state, in both cases, this state will also be active. So we can add a transition rule from this parent state. So we'll go ahead and add a transition. And so far, we've explored the on state completed or the on event triggers. This time we're going to select on tick, and we will transition to attack, but we'll add a condition to this transition rule as well. So we'll add a condition here, and we will select our compare gameplay tags. We will bind this to our motivation parameter, and we will check to see if our motivation has changed to alien motivation attack. And we'll just update our description as well. So if motivation is a match for alien motivation attack, we will transition to the attack state on tick. And now it's finally time to get down into the specific attack behavior that we want our alien to perform. So once we've transitioned into our attack branch, based on the selection behavior of selecting children in order, we will first select the has attack target, but we only want to enter this state if our alien has a direct line of sight to our player character. So we can add an enter condition of type bool compare. The left input, we will bind this to our can see target output from our evaluator. So we'll select our evaluator and then can see target, and we want to make sure that can see target is true. If can see target is true, we will then move down into our next child state, which is move to target. And for this one, we will add a task of type move to. Now you'll recall from the previous video, the move to task requires either a destination or a target actor. In the previous lesson, we used a destination, but in this lesson, we're going to use a target actor. And specifically, we're going to bind it to our acquired target output. So we'll select our binding here, then our evaluator, and then we'll select acquired target. For acceptable radius, I'll change this to 50, and we'll compile. And then we'll add a transition to our move to target. And on state completed, we will transition to the next state, which is wait. So we'll select the wait state, we'll add a task of type delay task, and we'll set the duration to 0.5 seconds. And then we'll add a new transition rule again, and then on state completed, we will transition back up to has attack target. Select has attack target, and then compile. So let's test to see how this is working so far. We'll go to our map and then press play. And press the tab key to get a bit more of a bird's eye view. And once we enter our line of sight, our alien is now chasing the player. Great. So that's all working really well so far. But we also want to add in some logic for when the alien loses sight of the player. And for this one, we're going to create a more specific gameplay tag for our attack motivation. So we'll go back to our content drawer, go to the alien folder and data tables, and we'll open up our gameplay tags table. And I'm going to add a new row, and we'll name this gameplay tag alien.motivation.attack.try-find-target. And then save. Go back to our state tree, and now we'll select our has attack target state, and we want to add a transition rule for when the alien loses sight of the player. So we'll add a transition rule. We'll select on tick. We will transition to search for attack target, and we'll add a condition of compare gameplay tags. The left tag input we will again bind to our motivation parameter, and this time we will select alien, motivation, attack, try find target. And this time we want to make sure it's an exact match. And we will specify the description here. So if our motivation parameter tag is an exact match for alien, motivation, attack, try find target, we will transition to search for attack target on tick. So go ahead and compile and save that. So now we'll select our search for attack target state. We will add an enter condition of type compare gameplay tags, bind it to our parameter. We want to make sure we have an exact match for try find target. And we'll also add in another enter condition of type bool compare. We will bind our boolean to evaluator and can see target and make sure that that is false. So if our parameter exactly matches try find target and our can see target boolean is false, we can enter this state and this branch. And then we'll branch down into the first available state, which is move to last known location. So now we actually need to get the last known location, and we'll do this from our evaluator. So we'll go back to our evaluator, and from our on target perception updated, if successfully sensed is false, that means that we have lost sight of the target. So what we'll do here is we'll get a reference to our received stimulus variable, select get. Then we will get sense class for stimulus, hook that up to false. And we want to make sure that this stimulus is equal to AI sense site. AI sense site. Add a branch. And if that is true, we'll create a new function and call this handle target lost sight. We will get a reference to the AI controller and select get, and we will clear focus. We will then set can see target to false, and to get the last known location, we will get a reference to the received stimulus and then break the stimulus, expand the option, and we want to get the stimulus location and promote that to a variable, and we'll call this last known target location and hook that up like so. We'll hide unconnected pins. And for this last known target location variable, we will also change this to the output category so that we can access it from our state tree. And finally, we'll make sure to update our motivation. So we'll get a reference to our motivation param, get property reference, get a set by ref node, and hook this up. Add the reference to target, and we will change the motivation to alien, motivation, attack, try find target, and then compile and save. We'll go back to our event graph. And then we'll add our new function to the event graph and hook that up to true. And just to tidy some things up a little bit, I'll get rid of this print string node that we had from earlier. And I'm going to select all of these nodes except for the two functions at the end. And I'll right click and select collapse to macro. Now, the reason why I'm selecting a macro is because a macro can have more than one execution output. Select the macro and we will rename this to handle initial stimulus info. In the inputs here, I will change the name of this input to input exec. For the first output, I'll rename this output exec. And for the second output, I'll rename this lost site. Compile and save. Now let's go back to our state tree. And we've now got a last known target location output variable in our evaluator. So we'll select move to last known location. We'll add a task of type move to. The destination we will bind to our evaluator and last known target location. And then we'll add a transition. On state completed, we will move to the next state, which will be wait. Select the wait node, add a task of type delay task, set this for 5 seconds. Then add a transition. On state completed, we will move back to the root. And then once we return to the root, it will then go down and select children in order and select the first branch where the conditions are met, which in this case will be search. So let's go ahead and test to see if this is working. What we'll do is we'll press play. I'll hit the tab key and I'll press the quotation mark so we can see the debug information. And we will move into the enemy's line of sight. And then I will go behind an obstacle. And you'll see that the alien has moved to the last known location and is now waiting. But it does not appear to be returning to its original behavior. So let's work out what's going on here. We stop that and we go back to our evaluator again. We need to make use of this event here, on target perception forgotten. So what we'll do now is we'll create a new function again. We'll call this handle target forgotten. And this will be really straightforward. We'll add our received any sent stimulus, set that to false. Received site stimulus, set that to false as well. We will add the acquired target, which will set that reference to nothing. And then finally, we will change our motivation. So we'll drag off our motivation param, get property reference, set by reference, hook up the reference to target, and then we will change our motivation to alien motivation search. And of course, we'll just drag this new function onto the event graph and hook that up to our forgotten event. Compile and save. So now when we press play, hit the tab key, go into debug view mode, and we'll run behind an obstacle. And now he's re-entered his default behavior. And one final thing that we should probably add before we move on is that when the alien has lost sight of the target, there is also the chance that they will find the target again. So we want to add a transition rule from search for attack target back to has attack target if the alien finds our player again. So we'll select search for attack target, and then we'll add a transition. Select on tick, we will transition to has attack target. We will add a condition of bool compare, and we will bind the left boolean to evaluate and can see target and mark that as true. And we'll also add in another condition of type compare gameplay tags, and we'll bind this to our parameter. And the tag we want to check is alien motivation attack. And this time we want to check if it's an exact match. And we'll just change the description here. So now let's test this out. Play, hit tab, enter debug view, enter our line of sight. And now if we re-enter the line of sight, the alien will attack us again. And one last thing we might do before finishing this lesson today is changing the alien's movement speed based on whether or not he's in a search state or an attack state. So to do that, I'll create a task. We'll go to new task and we'll select alien NPC base task. We'll save this in the ST tasks folder and we'll call this ST task underscore alien underscore change movement speed. And before we implement this task, we'll open up our character itself. So we'll go to blueprints, characters, and our alien character. Go to our content drawer, shoot content, blueprints, AI, alien. And I'm going to create a new folder and call this structs. And then right click, blueprint, structure. And we'll call this F underscore movement speed. Then open this up. So a blueprint structure is basically a container of other variable types. What we're going to do is create 4 different float variables, which will contain default values for 4 different movement speeds of our alien character. So we'll change the variable type to float and create 3 more. We'll name the first variable sneak. Second we'll call walk. Third one we'll call escalated. And the 4th speed will be attack. Save. We'll go back to our alien character, add a new variable, call it movement speeds, and this will be of type F underscore movement speed. And when we compile, we can set the default values in this area here. So for sneak, we'll set a speed of 100. For walk, we'll set a speed of 200. Escalated speed will be 350, and an attack speed will be 500. Compile and save. Now we'll go back to our state tree task. Select override, enter state. Then we'll get a reference to our alien character. We will get the variable movement speeds. It's this one here. We will right click and select split struct pin. We'll get another reference to our character. And this time we will get the character movement component. And we will set the max walk speed. Hook that up like so. And now we'll add in a new enum. So we'll go to content drawer, alien folder, and then under enums, right click, blueprint, enumeration, call this enum underscore movement speeds. Double click that, create 4 enumerators, sneak with the same name. So we have sneak, walk, escalated, and attack. We'll create a variable, call this select movement speed, and this will be of type enum underscore movement speeds. And we'll make sure to expose this to the editor so we can select it from our state tree. We'll drag this onto the graph as a get variable and then type in select. And then we will just hook these up like so. And then hook the return value into set max walk speed. So based on the movement speed that we will select, it will then set the max walk speed based on the default float values that we defined in our character. So we'll compile that, save, go to class settings, blueprint categories, alien NPC behavior, blueprint display name will be set movement speed, compile, and then go back to our state tree, and then under this search task, we will add a task of type set movement speed, and we will set the speed to walk. Now we'll select the attack state and add the same task again, set movement speed, and this time we'll set it to attack. Compile and save. Now we'll go back to our level and test this out. When we press play, by default, the enemy will be walking. And once it changes to an attack state, it will change to an attack speed. So there you have it. We've covered a lot in this lesson, but now our alien character will change its behavior based on whether or not it can see the player. In the next lesson, we'll be implementing prediction sense, which will allow our alien NPC to predict where our player character is going after the alien loses sight of the player character. I hope you enjoyed this lesson. Please like the video and subscribe to the channel. Leave a comment to let me know how your learning is going, and I will see you in the next video.